Okay, now that we have reviewed interval notation, what we're going to do is we are going to solve linear inequalities, and then we're going to write our answer using interval notation. Now, when we are solving linear inequalities, we would solve them just like we were solving a linear equation, with the one extra rule is if you multiply or divide by a negative number, you have to switch the direction of the inequality sign to keep the statement as a true statement. So, I know that this is a linear inequality because I've got an inequality in here instead of an equal sign. And I also see that all my x's have at most an exponent of 1. That tells me it's linear versus it possibly being a quadratic or a cubic or some other equation. I see that my degree is 1. So I know this is a linear inequality and I can solve it just like a linear equation with the one extra rule. So I'm going to go ahead and start solving this. The first thing I want to do is I want to distribute that -4. So I have -4 times x, and the -4 times the -1 is going to give me a +4. And I'm going to carry everything else down. And then I'm going to combine like terms. So I have the 4 and the 2 on the left I can combine and make that a 6. And then on the right-hand side, I can combine the 3x and the -4x to give that a -x. Now, just like this was an equal sign, I want to get all my x's together on one side and all my constants on the other side. So I'm going to add x to both sides. That would give me a -3x plus 6 is greater than -1. So I added an x to both sides. Now I'm going to subtract a 6 from both sides. And that's going to give me a -7 on the right. Now my last step is to divide both sides by -3. But here we have the situation where I'm dividing by a negative number, so I have to remember to switch the direction of my inequality sign. So I'm going to switch that direction, and I have a -7 divided by a -3, which makes it positive because I have a negative divided by a negative. And so here is my answer in inequality notation. But we want to practice putting this in interval notation. So to put it in interval notation, I'm going to look at the number line. Here's 7/3. Our answer says I want everything less than 7/3, not including 7/3. So I'm going to put a circle above 7/3 to indicate we're not including it. And I'm going to put my arrow to the left because we want everything less than that. Now, to write my final answer, on the left-hand part of my interval, that's going to -infinity. The right-hand side of my inequality is 7/3. 7/3 is not included, and of course we don't include -infinity. So this is my final answer written in interval notation. So what that means is if I pick anything less than a 7/3 and I plug it back into my original equation, or actually my original inequality, I'm going to get a true statement. If I plug in something that's greater than 7/3, then I'm going to get something that is a false statement because that would be something that is not in my solution set. Okay, the next example. Again, I noticed that this is an inequality, not an equation. So I have to remember about that extra rule if we come across that situation of multiplying or dividing by a negative number. I also notice that this is a linear inequality because all my x's are in the numerator and they all have a degree of 1. So my particular preference is to multiply through and get rid of the denominators so I can have whole numbers and not worry about the fractions. Now, to clear the fractions, I have 4, 7, and 14. 28 goes into all of those. So I'm going to multiply everything by 28. Okay, when I multiply 28 times the first term, the 4 goes into the 28 and leaves me with a 7. So I have 7 times x plus 5. When I look at the next term, the 7 goes into the 28 and I'm left with a 4. So I'm left with 4 times x minus 4. And then when I look at the last term, the 1 over 14, the 14 goes into 28 twice. So I'm left with the 2 times the 1 on the top, which is just 2. So now I can go ahead and distribute. So I have 7x plus 35 minus 4x plus 16 is less than or equal to 2. I can combine my like terms. So I have a 3x, and then the 35 and the 16 give me a 51. And then I'm still left with less than 2. Now I'm going to subtract 51 from both sides. So that's going to give me a negative 49 on the right-hand side. And I'm going to divide both sides by 3. Now I'm not dividing by a negative number, so I don't need to switch the sign. So I have x is less than or equal to negative 49 over 3. So this is my answer in inequality notation. To answer it in interval notation, I'm going to look at my number line. I have negative 49 over 3 on my number line, and I want all the numbers less than or equal to 49 over 3. So I'm going to do a closed circle because I'm including it, and I want everything less than that. So then my left-hand side goes to negative infinity. My right-hand side is the negative 49 over 3. The negative 49 over 3 is included, and of course the infinity is not. So this is my final answer in interval notation. So if I pick anything on that interval and I plug it back into my original equation, it should give me a true statement, such as 7 is less than 10, or something like that where you know it's true. If I plug in something greater than 49 over 3, then it's going to give me a false statement when I plug it back into my original inequality, such as 10 is less than 8. Then you know something's not right, and that's not part of your solution set. Okay, last example. This is a linear inequality. I see the inequality, so I know it's an inequality problem. And I know it's linear because all my x's have exponents of 1. And again, it has fractions. So first I want to try to clear the fractions. And in our denominator, we have 4, 2, and 3. So 12 will work for that. So I'm going to multiply everything by 12 to clear the fractions. Okay, when I multiply the negative 1/4 x times the 12, the 4 goes into the 12 and I'm left with a 3 on top. So I have a negative 3x. When I multiply the 12 times a negative 1/2, the 2 goes into the 12 and I'm left with a 6. And with the negative 1, that leaves me with a negative 6. And then with this last term here, when I take 2/3 times 12, the 3 goes into the 12 4 times, so I'm left with 4 times 2 on top, so that gives me an 8x. Okay, so now we have this broken down. It's a little bit easier to solve without the fractions. So I'm going to combine my like terms. And I don't have anything on each individual side that I can combine. So my next step is I'm going to subtract 8x from both sides. So that's going to give me a minus 11x on the left, if I subtract 8x from both sides, and a minus 6 on the right. Now I'm going to divide both sides by negative 11 to finish solving for x. but I'm dividing by a negative number, so I have to remember to switch the inequality sign. And I have negative 6 divided by a negative 11, which would end up being a positive because I have a negative divided by a negative. So this is my answer in inequality notation. If we put this on the number line to help us put it in interval notation, I have 6 over 11. The inequality doesn't say to include the 6 over 11, so I'm going to use open circle. We're not including it. And it says everything greater than 6/11, so that means I'm going to the right. So the left-hand part of my interval is going to be the 6/11, and the right-hand side of my interval is going to positive infinity. And I'm going to use parentheses for both because I'm not including the 6/11 and we never include the infinity. So this is my final answer written in inequality notation. So as long as I pick something greater than 6/11 and plug it back in to my original inequality, I should be getting a true statement. If I plug in something less than 6/11, then I'm going to run into a problem and I'm going to get a false statement, which tells me that it's not within that solution set.